So stepping back before we dive into sort of AI infrastructure alliance, any type of big enterprise system, I'll keep using enterprise because they have the most complex IT stacks. Any big system like that, there's always been this sort of age-old debate. Do we go, end-to-end system from one vendor, kind of, let's say, the NetSuite model? I always like to use that example in the early days where they're like, we do every function in the enterprise, but we do it like 3 inches deep. Versus the Salesforce model, which is we're just going to do CRM 20 years ago. We're going to do CRM. Only going to do sales. We're going to go super deep, and we can work from one user up to 10, 100,000 users, right, of sales folks. And then they sort of work their way out. So they went, mile deep and an inch wide, and NetSuite did an inch deep and a mile wide. And maybe to simplify that, it's kind of like, do you do the end-to-end thing, or do you buy a bunch of components, best of breed components? So suite versus components. That's the age-old thing. And I think you and I probably agree that it's not always either or. Sometimes it's, we buy an end-to-end system that sort of is the backbone, and we also have these components that go deep in certain areas. So it can be really additive. Give me your thoughts on that general set of patterns, and then let's dive into sort of where Aya fits into this.
Yeah, so at this stage in the evolution of infrastructure, the only end-to-end solution that exists is in the minds of marketers.
That's a contentious statement. I think Google's Vertex team and maybe the SageMaker team and the Azure ML team might take issue with that.
They might, but their marketing teams are the only places where those are 100% end-to-end systems, right?
All right.
And look, this is a fact. Look, I mean, I've had research teams looking at all these different platforms, right, and running them through their paces, and separating the kind of marketing hype from reality, right? And I have no doubt that they have the aspiration to become end-to-end systems.
Yeah.
But where you really look, they are actually a series of kind of bespoke tools that don't always perfectly play nice together, and they do some things incredibly well. I mean, look at something like Databricks and Spark, right? Okay, a fantastic platform, one of the early pioneers in the space, but also understand that Spark was created before AlexNet, right? So, and you're retrofitting a lot of machine learning into that space, right? And there's kind of this onset now with their kind of data lake, for instance, which I think is fantastic in many ways, but it's also this idea that it unifies structured and unstructured data. It's generally not true. I think there's one example of unstructured data on the entire site, and it's images, but there's no audio and video. And why is that? Because it's essentially a database structure under the the paraquet file, right? And you can only shove so many giant videos for editing or 300 gig satellite images into that space. So you need some kind of file-based system to be able to deal with that unstructured data. And yet, structured data is incredibly performant in databases. And so using them for log prediction and churn prediction, these kinds of things are fantastic.
Right.
But let's not pretend that it's also the unified solution for unstructured data, dealing with like doing deep fake lip syncing for audio dubbing, like we're starting to see happen now, or crunching through satellite images.
Right. You wouldn't process 1 trillion images. It's not designed for that.
Right, you're not going to do it. And again, so the marketing tells you that you're able to do that. And if you look at most of these systems, I'd say most of these systems are almost 100% focused on structured data, right? You look at 90% of the monitoring systems out there display what's easy to display in structured data.
Right.
You look at most of them have a database backend, which is fine. But you have all these interesting things. You have genomics, you have audio video, you have giant high resolution imagery, and you have unstructured text. By the way, 80% of the text out there is unstructured. So you have a whole series of tools out there that claim to be sort of end-to-end, but really you don't have to dig very deep to understand that it's not the case. So I think you're really always going to need, you could have one of those systems as a backend, but if the team sort of believes, and maybe it's enough for just the use case you're doing. Maybe you're only doing housing pricing prediction or churn prediction or whatever. You only have structured data. Great, you're fine. But if you want to then start to expand into kind of multiple other layers, you're in trouble. And I think one of the things you talk about with your kind of consulting firm is you want to build for the next decade. And to do that, you want to have a number of solutions that a lot of different teams are going to be able to utilize and standardize on, not just a single solution. And what ends up happening is a lot of times you hire one data science, data engineering team, they pick like the one tool for that job, and then they kind of expect to generalize out to the other ones. And it's just like AlphaGo being retrained on cats, right? And it suddenly doesn't work, right? So, my thinking is you have to have a more comprehensive strategy. You're going to have a lot of these different pieces, and frankly, you're going to have them for a long time. There's not going to be a VMware in this space for 5 to 10 years that's able to kind of, because the field is still developing, like we talked
Right.
about earlier,
Right.
right? There's no, we don't have the O'Reilly book on the best way to develop synthetic data, right? We don't have the O'Reilly book on the best way to do auditing and compliance for an auditor who wants pulled out of a facial recognition database or wants to audit, 5 years of inference predictions for bias.
Right.
Those tools don't even exist, but they're going to have to exist. So
they're all being built right now.
They're all being built right
you
now.
often say, what? There's no lamp stack for machine learning.
There is no.
So first explain lamp stack, and then explain what that means in this context. For folks who may not be familiar with that, you lived that life.
Right. So yeah. Now I'm dating.
You forget what you know.
Yeah. So I mean, look, in the early days of the internet, right? All of a sudden, everybody's rolling their own solution. They're pulling from one of 20 different web servers. They don't know which language they're going to use. Like they have to build their own deployment system. They have to build their own system for how they manage their website and what it looks like. And then over the course of time, right, you start to get these kind of general solutions to this problem. So the LAMP stack was one of the first ones. It was Linux, PHP, Apache, and MySQL. So that was your database, your language, your web server, et cetera. And all of it, and that enabled the development of other types of technologies. Once you have these foundational technologies that most people are going to look to as the default solution, the first solution,
right?
You move up the stack to solve other problems. So you get something like WordPress, which now runs 50-60% of the words, on the thing. And then from there, you get a drag and drop editor theme that sits on top of that, where now like a chucklehead designer like myself can actually, pull together a reasonably decent looking site without, knowing how to write XML and a bunch of other code on the back end to make it beautiful. Right. And so these types of things can't develop without the foundational technology. My sense is there's no LAMP stack for artificial intelligence. And what we're going to have is Darwinism over the next, 5 to 10 years, where a lot of people are going to compete. A lot of people are going to, there's a lot of money pouring into the space. You got billion-dollar valuations for, people writing how to sneeze in AI, right? And all of a sudden, it's like some of those are going to obviously collapse, or they're going to merge, and you're going to have. I always say in the AI Infrastructure Alliance, we'll talk about in a minute, is we might as well all work together now because we're all going to be working together anyway, right? In
That's
other words,
right.
Companies.
We're gonna all get 5 of us are gonna end up being acquired by the same, parent company or something next week probably, or next month.
Right. And one of the startups runs out of money, it fails, and we end up in another one, and
exactly.
or you have an idea for one of these spaces that nobody took seriously, and you start your own company, and all of a sudden, this is how it works. When you look at the early phase of any technology, they look at the car industry, right? And they go, well, there's like 4 or 5 car companies in the world. Yeah. In the United States, there were about 100 in the early days of when Ford and all that stuff is.
There were actually several hundred.
That's right. And they all consolidate down. And they could be there for building windshield wipers, and just right. And yes, you have a lot of companies that now supply the big companies.
Right.
But it took a long time for those kind of companies to consolidate down on the correct solution, the correct design pattern for building a car. Same thing's going to happen in artificial intelligence. We're going to take a while to converge on that correct design pattern, and it requires a lot of failure. Failure is not a bad thing. Failure is the sign of progress. It's a sign of evolution. It's how we learn. It's how economics grow. It's how industries grow.